All right, we are still in the Unit 3 System of Equations packet, and today we're going to be on pages 15 and 16. So, in the previous notes video, we looked at using the elimination method, and in all the examples we completed, they had common coefficients. Now, today we're going to talk about what if there is no common coefficients. So, in the little lines right next to that question, we are going to put multiply one or both equations by some number to create common coefficients. All right, so looking at number one, so when you start a system of equation problem using elimination and there's no common coefficients, the first thing you have to decide is if you want to eliminate x or if you want to eliminate y. Okay, it does not matter what variable you eliminate first. Okay, if you work it out correctly, you will still get the same answer in the end. So some of them I'm going to eliminate x, some I'm going to eliminate y. There's no particular reason behind that. Okay, because you're still going to get the same answer. So, looking at number one, we have x plus 3y equals 6 and x minus 7y equals negative 1. So, in this particular example, I'm going to be eliminating x, okay, because this x doesn't have a visible number beside it, so that's going to make this problem a little bit easier. Okay, some of those you won't have that option, but for right now, that's why I'm eliminating x. So, there's a 1 in front of this x. Now I have to figure out what I have to multiply to that equation in order to get a 2 beside it. Okay? I don't care about the other numbers. I don't care about the 3y or the 6. I just want to figure out what I have to multiply to the 1 right here to get a 2 beside it. So we have to multiply a 2 because 2 times 1 equals 2. So, now that I figured that out, I'm going to multiply the entire equation by 2. So, I'm going to be using the distributed property in order to do that. So, 2 times 1x is 2x. 2 times 3y is 6y. 2 times 6 is 12. All right, now when I'm solving this problem, I'm going to be looking at these two equations right here, okay? So looking at that equation, okay, I noticed that my x's have a common coefficient and they both have the same sign. So that means I'm going to subtract. So 2x minus 2x is 0. Those cancel. Negative 7y minus 6y is negative 13y. And negative 1 minus 12 is also negative 13. All right. Now I got to solve for y. So my last step would be to divide both sides by negative 13. So y is going to equal 1. Okay, just like in other problems, you want to put this back into one of your original equations, okay? So that would either be, this equation or this equation. And just like before, it does not matter which one you pick. So I'm going to plug it into the first one. All right, and then I'm going to solve for x. So this is x plus 3 equals 6, because 3 times 1 is 3. Then I'm going to subtract 3 from both sides, so x is going to equal 3. So that's 3, 1 would be our answer there. All right, let's look at another example. Number 2, we have 9x plus 3y equals 12 and 2x plus y equals 5. So I'm going to decide to eliminate the y variable because this y in the second equation doesn't have a visible number beside it. So since I'm eliminating y, they both need to have the number 3 in front of them, so then we can have a common coefficient. So I'm going to take my second equation and I'm going to multiply it by 3. So we're going to use the distributive property. So 3 times 2x is 6x, 3 times y is 3y, and 3 times 5 is 15. All right, then I'm going to take my top equation and just copy it down right underneath that. So now I can solve this system of equations. So I have common coefficients with y. They're both positive, so that means I'm going to subtract. So 6x minus 9x is negative 3x. 3y minus 3y is 0, so they cancel. And 15 minus 12 is 3. My last step to solve for x is to divide by 3, or divide by negative 3 on both sides. So x is going to equal negative 1. All right, then I'm going to pick an equation to plug that into. Remember, you want to pick one of your original equations. Okay, I'm going to choose the second one. And I'm going to substitute a negative 1 in for x. And then I'm going to solve this for y. So I need to get rid of the parentheses first. So that's negative 2 plus y equals 5. Then I got to get y by itself. So I'm going to add 2 to both sides. So y is going to equal 7. So then my answer is negative 1, comma 7. All right, number 3. We have 3x minus y equals 14 and 5x plus 4y equals 12. So I'm going to choose to eliminate y because in that first equation, y does not have a visible number beside it. All right, so in order to eliminate it, I need it to have a 4 in front of it. So then we can have common coefficients. So I'm going to multiply my whole top equation by 4. So using the distributed property, don't know why I can't say that today, I'm going to multiply everything by 4. So 4 times 3x is 12x. 4 times negative y is negative 4y. And 4 times 14 is 56. All right, now looking at these two equations, I have a common coefficient with y, and they have different signs. So this time, we are going to add our equations together. So 5x plus 12x is 17x. Positive 4y plus negative 4y is 0, so those cancel. And 12 plus 56 is 68. All right, my last step is to divide both sides by 17. So x is going to equal 4. All right, now I'm going to plug that into one of my original equations. I'm actually going to plug it into the second one this time. All right, so I'm going to multiply 5 and 4 together, and that gives me 20. Now I need to get 4y by itself, so I'm going to subtract 20 on both sides. So 4y equals negative 8. And then we're going to divide both sides by 4. So y is going to equal negative 2. So my answer is 4, negative 2. All right, let's do another one. x plus y equals negative 3, 5x minus 2y equals negative 50. All right, so this one, it truly does not matter which one you want to eliminate because in that top equation, x and y do not have a visible number beside it. So I'm going to eliminate y. So that means I need to get a 2 beside this y, so I'm going to multiply my whole equation by 2. So 2 times x is 2x, 2 times y is 2y, and 2 times negative 3 is negative 6. All right, so I have common coefficients with y. They have different signs, so we are going to add our equations together. So 5x plus 2x is 7x. Negative 2y plus 2y is 0, so those cancel. And negative 50 plus negative 6 is negative 56. Now I'm going to divide both sides by 7, so x is going to equal negative 8. Now I'm going to plug that into one of my original equations. So I'm going to choose the top one. But like I said, it doesn't matter which one you pick. I'm going to plug in negative 8 for y. And I'm going to plug in negative 8 for x, and I'm going to solve for y. So then to get y by itself, I'm going to add 8 to both sides. So y is going to equal 5. So negative 8, comma 5 would be our answer. All right, if you would like to do number 5 as extra practice, the answer for you is negative 4, negative 3. Okay, if you want to do that one for extra practice. Now let's flip over to page 16. All right, number 6 we're going to do because it has one of those special solutions. So we have 3x plus y equals 2 and 6x plus 2y equals 4. So I'm going to choose to eliminate y because there's no visible number beside it, and I want it to have a number 2. So I'm going to multiply my whole top equation by 2. So 2 times 3x is 6x, 2 times y is 2y, and 2 times 2 is 4. All right, this time x and y both have common coefficients and they're both positive, so that means we're going to subtract. So 6x minus 6x is 0, 2y minus 2y is 0, and then on the other side 4 minus 4 is 0. So everything canceled out, so that means we're going to have an infinite amount of solutions for that one. All right, number 7, 3x plus 4y equals 6, 7x plus 8y equals 10. So now I'm looking at an example where there is not a number, or there's not a letter with a visible number beside it. Okay, they all have visible numbers, so I can't just easily pick one this time. So now you really have to decide if you're going to eliminate x or y. I'm going to choose to eliminate y, but you could also use the same method to eliminate x. It doesn't matter. So looking at y, I have 4 and 8. So I need to find the least common multiple of those two numbers so I can decide what I need to multiply my equations by. So if you're not very good with your multiples, I would suggest writing it out. So I'm going to make a list of my 4 multiples, which are just when I multiply something to 4, what do I get? So 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, then 16, 20, 24, so on and so forth. All right, multiples of 8 are 8, 16, 24, 32, 40, 48, so on and so forth. So looking at those two lists, I want to pick the smallest one where they have, I want to pick, how do I want to say this? I want to pick the smallest number that they have in common. So in this case, it would be 8. Okay, that's the smallest number that they have in common. So I need to figure out what I have to multiply to these equations so they both have an 8 beside y. My second equation already has an 8, so I don't have to multiply anything to that equation. But I have to figure out what I have to multiply to 4 to get 8, which would be 2, because 4 times 2 is 8. So I'm going to take my top equation, and I'm going to multiply the whole thing by 2. So using the distributive property, I'm going to do 3x times 2, 3x times 2, which is 6x, 2 times 4y, which is 8y, and 2 times 6, which is 12. So now looking at these two equations, I have a common coefficient with y. They're both positive 8, so I'm going to subtract. So 7x minus 6x is 1x. And then 8y minus 8y is 0. 10 minus 12 is negative 2. So x equals negative 2. Okay, then just like before, I'm going to plug it into one of my equations. So I'm going to choose the top one. And I'm going to replace x with a negative 2. 3 times negative 2, negative 6. Now I got to get 4y by itself, so I'm going to add 6 to both sides. And then I divide by 4, so y equals 3. So negative 2, 3. All right, let's do another one so that it'll make a little bit more sense. All right, number 8, 3x plus 3y equals 9, 5x plus 4y equals 10. So we have to figure out if we want to eliminate x or if we want to eliminate y. So for this example, I'm going to eliminate x. So I have 3 and 5. So I'm going to list my multiples of 5 and then find the smallest number that they have in common. So my multiples of 3. 3, 6, 9, 12, 15, 18, 21, 24, so on and so forth. Okay, for 5, I have 5, 10, 15, 20, 25, 30, so on and so forth. So looking at my two lists, the smallest number that they have in common is 15. So I'm going to multiply my top equation by 5 because 3 times 5 gives me 15. And I'm going to multiply my bottom equation by 3 because 3 times 5 gives me 15. So I'm going to have 5 times 3x is 15x. 5 times 3y is 15y. And then 5 times 9 is 45. Then for the bottom equation, I have 3 times 5x is 15x. 3 times 4y is 12y. And 3 times 10 is 30. So now looking at those two equations, my x's have a common coefficient. They have the same sign, so I'm going to subtract. 15x minus 15x is 0. 15y minus 12y is 3y, and 45 minus 30 is 15. Then our last step is to divide by 3, so y is going to equal 5. Okay, just like any other problem, I'm going to take that 5 and plug it into one of the original equations. So I'm going to choose the top one. And I'm going to replace y with the number 5. So 3 times 5 is 15, so that gives me 3x plus 15 equals 9. I need to get 3x by itself, so I'm going to subtract 15 from both sides. That gives me negative 6. So I'm going to divide by 3. So x is going to be negative 2. So my solution will be negative 2, 5. All right, number 9. We have 5x plus 9y equals negative 10, 7x plus 10y equals negative 1. All right, so we're going to choose a variable to eliminate. I'm going to choose to eliminate x. So I'm going to have 5 and 7. I'm going to list my multiples of each and then find the smallest number that they have in common. So 5, 10, 15, 20, 25, 30, 35. And then 7, 14, 21, 28, 35, 42. All right, so looking at these two lists, that could go on forever, okay? But the smallest number that they're going to have in common is 35. So I'm going to multiply my top equation by 7, because 7 times 5 will give me 35. And then I'm going to multiply my bottom equation by 5, because 5 times 7 will give me 35. Okay, remember we're going to multiply the whole equation. So 7 times 5x is 35x. 7 times 9y is 63y. And 7 times negative 10 is negative 70. All right, for the second equation, 5 times 7x is 35x. 5 times 10y is 50y. And 5 times negative 1 is negative 5. So now with my two new equations, x's have the common coefficient and they have the same sign, so I'm going to subtract. So 35x minus 35x is 0. 63y minus 50y is 13y. And then negative 70 minus negative 5 is negative 65. So I'm going to divide both sides by 13. So y is going to be negative 5. Now I'm going to take that negative 5 and plug it into one of my original equations. So I'm going to choose the first one. And I'm going to change the y to a negative 5. So 9 times negative 5 is negative 45. Now to solve for x, I need to get 5x by itself. So I'm going to add 45 to both sides. And then I'm going to divide by 5. So x equals 7. So my answer will be 7, negative 5. All right, I'm going to skip 10. If you want to do it by yourself, the answer is 3, negative 3. And I'm also going to skip number 12 but the answer is 1, -4 if you want to do that one. We're going to do 11 together because it is also another one with one of the special solutions. So, looking at this one, our equal signs are not lined up, which is something that we really haven't looked at today, but we talked about it in the previous notes video. All you have to do is make sure that your x and your y are lined up like in the top equation. So, in this instant, the second equation, that -6y needs to move to the other side. So I'm going to add 6y to both sides. And then now that it's lined up, I'm going to rewrite the equations right below it, or the top equation right below it. All right, looking at this now, we do not have common coefficients. So I need to figure out what number I need to multiply the top and the bottom equation by to where we get common coefficients. So I am going to eliminate the x's. So I have 3 and 2, and I'm first going to list my multiples. So 3, 6, 9, 12, 15, 18, so on and so forth. And then 2, 4, 6, 8, 10, so on and so forth. So if you look at this list, we can see that the smallest number that they have in common is going to be 6. So I need to figure out what I have to multiply my top equation to get 6 by x. So that's going to be 2, because 2 times 3 is 6. And then I'm going to multiply my bottom equation by 3, because 3 times 2 is 6. So now I'm going to use the distributive property to do that. So 2 times 3x is 6x. 2 times 6y is 12y. And 2 times 12 is 24. Then I'm going to do the bottom. 3 times 2x is 6x. 3 times 4y is 12y. And 3 times 6 is 18. I ran out of room, so I'm going to rewrite these equations. Oh, whoops. Up here. All right, so now our x and our y have common coefficients. Okay, both the x's and the y have the same sign, so that means I'm going to subtract. So 6x minus 6x is 0. 12y minus 12y is 0. And then 24 minus 18 is 6. So we're left with 0 equals 6, which is not a true statement because 0 does not equal 6. So that means we're going to have no solutions for this system. All right, so that ends the notes on the elimination method where there is no common coefficient.